Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to this experiment lab number 7 in the ALET 301 course. In this experiment, we're going to talk about sampling mainly. The goal of this experiment is to cover the sampling theorem, and this is in the time domain and frequency domain. We're not going to discuss the aliasing, and we're not going to discuss the recovery. We will focus on the sampling theorem, and the main part is the minimum sampling rate, which is known as Nyquist theorem. What is sampling? Sampling is taking a sample of a signal. So here is the original sample. Here is the original signal. So normally we will call it original signal. So analog signal is the original signal, and we will convert this analog signal to the digital signal as shown here. So if we want to go from analog signal to digital signal, there is a procedure, and the first step is the sampling. So there are quantization and encoding, and these are not covered. We will focus on the sampling over here, which is the first step. So after sampling this signal, what we will get is we will get these shape. So if we sample in the right rate, right frequency, we will be getting similar shape to the original signal. So this is the original signal. If we connect between these points of samples, then we will get somehow similar to this original signal. Now, let's take some examples. So if this is the original signal and we get samples as shown over here, here is the samples, and if we connect between them with linear lines, we will get this shape, and if we connect with the curved lines, we will get similar shape to the original signal. If we increase the number of samples, increase the rate of sampling, we will get this, and this will be much closer to the original signal. If we decrease this number of samples, decrease the sampling rate, we will get far away from the original signal. So this is not similar anyway to the original signal. So increasing the sampling rate is good to get better shape, and decreasing the sampling rate is bad where it does not give us a good shape. But there is a price we have to pay for increasing the sampling rate. Number of samples is more, and we need more memory to have that signal. In the frequency domain, this is the original signal shape. If we do a Fourier transform, this is the original signal at the frequency range. And if we do the sampling in the perfect way, we will be able to reconstruct the same signal again. This is not covered, I will skip it, the aliasing. Now, this is the steps of sampling. So what is in the time domain? The sampling is just multiplying the signal with a train or several impulses. These deltas multiplied by this, we will get this shape, sampled frequency. If this train was dense, so many impulses, very high number of impulses in the same period, we will get a better shape. If this is less number of impulses, we will get a bad shape. So in the frequency domain, this shape is changed by the Fourier transform to this shape. Now, multiplication will be changed into convolution. The impulses will be changed to another impulses. The separation here is Ts for the sampling, and here is Fs for the sampling, which is 1 over Ts. So the reciprocal. The more we sample here, the far away from here, the less we will have here. More, less. So if more number of samples is here, we will get less number of impulses here. And therefore, these impulses will be separated more. Once this is separated, these shape will be separated. So convolving this with impulses is duplicating this shape on each impulses. If we separate them far away from each other, these will be separated far away from each other, which is good. So what we get is that this is the shape of the signal after we do the sampling. In fact, we need to keep noticing that in this we have from the 0 till here is the maximum frequency in the signal. So the width from one side to another side is 2 FM. This is called FM. The maximum is called FM. So the two of them will be 2 times FM. So the width of this frequency is 2 FM. If we sample in a way that the separation between these two, which is Fs, is greater than FM, 2 FM, these will be separated from each other. If it was not right, then these will be overlap. There will be an overlap, which makes a problem for us. Now, let's take this signal and put it here and do reconstruction. So what is reconstruction? Is I want to get back to the original shape. So in the frequency domain, I just need to multiply this by rect function. So this is 1, we will get this signal. All other places will be 0. This will be go to 0, will be removed. So we will get the original signal as we can see over here. In the time domain, the multiplication will be convolution, and the rect will be sinc function. So if we convolve this with sinc function, we will get this signal, which is somehow close to the sampling, to the original signal. Now, what happens if we go below the Nyquist rate? So if we go below the Nyquist rate, the separation between these will be less. So this will be duplicated in a way to get this shape. So it will repeat here and here and here. But there is no space, enough space to separate between the two FM. So we will get an overlap between the signals. And after we reconstruct, if we multiply this by rect, we will get this shape, which is a bit different than this shape. And this will be clear if we could see it here. So these original signal and the recovered signals, which is a little bit different. Okay, so in the Matlab, what you need to do is the following. So in this presentation, there is some additional tasks that you have to do in the top of the lab manual. So follow the instruction in the lab manual to complete the lab report and do the additional part as mentioned in this presentation. So if you do the lab manual from the first few steps, you will get somehow similar shape to what you can see over here. So this is the original signal and this is after sampling. What do you think? Is this and this similar? No. So there is a big difference between these two signals. And if you connect between the points here, you will not get this signal. So what we need to take more samples to get somehow similar to the original signal. This is what we need to do. We have to get more samples, as you can see here. And by this, if we connect the samples points here, we will get to the original signal. Now, in part 1, follow the instructions from step 1 to 5. These pages. Then plot these signals and give me the answer to this question. Do you think you have sampled correctly? Are they similar or not? The sampled and the original signals. Now part 2, you need to decrease the fs. Now, how many samples we need to do? Just decrease it further and see if this is the right direction that we have to go with. So start decreasing fs, pick two values of s. Let's say if it was like 0.1, go with 0.05 or 0.01, whatever, and check the effect on the signal shape after sampling. Do the following in the Matlab. Plot all examples and compare fs with fm. And what do you think again? Is that the right direction? Are we going to the right direction when we decrease fs, or should we go with the opposite direction? Let's see if we increase fs. Now let's flip the direction, increase fs. Now you have to maintain in both steps fm the same, so do not change the signal's frequency, only the sampling frequency, the sampling rate. And pick 4 values and check the effect, especially when you go beyond the Nyquist rate, so beyond 2 fm, and plot all these things. And this is what you will see the importance of going beyond the Nyquist rate, more than 2 times fm. Now, in the last part, they ask you to do a decrease for the original frequency. Now, go to the original frequency and change the frequency. Original signal, change the frequency. Now, if we decrease the frequency of the signal and see how this will go with you. And this is, in fact, step number 7. Take more than one value, so pick 3 values and plot them for me. That's it. This is the lab. I hope you could have solved it easy. And if you have any questions, please post it to me. I'll be more than happy to answer it. You have the email, you have the Google chat, and all other media. Thank you so much, and let's meet you in the next lab. Thanks. Assalamu alaikum.